Hello, everybody. Nice afternoon, at least in Central Europe. We are really overwhelmed how many of you have registered for that webinar. We definitely are scratching the limits of the technical solution for this webinar system. My name is Andres Hildebrand. I'm responsible for marketing and education at Maxon. And with me are Thomas Schlick, RealFlow specialist at Next Limit, and also Thomas Andreasen, the main person in that webinar. Thomas is a very, very experienced Cinema 4D artist. He's also lead instructor for Cinema 4D in the Scandinavian countries. And he started using RealFlow just recently. And we came to the idea that it might be a good idea to show you who might not have touched RealFlow out of um, cautiousness, whatever, because simulation is said to be very complicated. Well, Thomas will show you that it's not rocket science. I hope you enjoy this presentation. Please keep in mind this is not a support session, so you can of course ask questions in the chat, and we'll take at least 10 minutes at the end of the webinar to answer your questions and maybe show a little bit. But if you have questions, please type them down in the chat window. We will copy all messages that we get from chat, and we will prepare a little Q&A leaflet that you will get in one of our follow-up emails. So, Thomas, handing over to you.
Thank you. Thank you. Well, my name is, as Andres said, my name is Thomas Andreasen. I'm from Denmark. I'm running my own little 3D studio, doing all kinds of 3D projects, both animation and still imaging, and and also the instructional part of cinema, teaching Cinema 4D in Scandinavia, and demoing at trade fairs and so on. So, and as Andres said, I'm a rather experienced Cinema 4D user. I can't remember exactly what year I started, but it was with version 6, and we're now up to 17, so I've gone through 11 upgrades. So I have a great deal of experience with Cinema 4D, but I've always stayed away from liquid simulations because I've always had the idea that that was too difficult. You needed a rocket science degree to be able to get something worthwhile out of it. And although there is a learning curve, as with all kinds of software, and especially 3D software, it is pretty straightforward once you get to know the basic workflow of the application. And it's definitely, for me, knowing cinema pretty well, it's rather easy to get started using RealFlow, at least. All the Hollywood visual effects stuff, well, that's out of my range because I'm not that experienced with RealFlow. But for the smaller projects, motion graphics projects, like the small commercial I'm walking through today, it's a very good solution, and it's rather simple with all precautions, because nothing in 3D is simple, but this is pretty good and pretty easy to make. First of all, I'm going to be showing you the final commercial. It's a project that's been designed for this webinar. So it's not a real product, it's just something that's been made up for this event. We're going to be going through the entire process from creating the stuff in Cinema 4D, sending it to RealFlow, doing the simulations there, back into Cinema 4D, and then after rendering into After Effects and a bit of post-processing. So, let's get on with it. The first part here is the ad itself. So this is it. The idea behind this spot was I wanted this the shape of the bottle here to mimic some kind of flower that hadn't opened yet. So I made the bottle, and I made the outside petals and made them open as we go through time. They open and they reveal the bottle inside. And while this is going on, I want the liquid to, or the perfume, to rise upwards and hover above the object here. And then when it opens, everything falls down and pours outwards. So we reveal the bottle here. So this was the idea. And although it took a bit of back and forth between Cinema and RealFlow, it's something that was accomplished pretty quickly. Okay, so let's get started inside of Cinema 4D. Here we have the scene. I'll press play. We go around, the flower start, or the flower opens, and we have a few camera shots here. And let's stop it again. First of all, the flower is modeled. I'll just turn this one off, and I'll go outside this. I'll explain everything later in the process. Here we have the flower. That's just a one petal. It's a very simple shape, made of plane and extruded and modified. Then I've added it to a subdivision surface object. And as you notice, my null is in here, inside of the center here. So I moved the null in here to make it easier, or to prepare for the MoGraph cloner here. So what happens is we have this MoGraph cloner. As you can see in here, we have, just move this up, 7 copies of the petal with a certain radius. And then as time passes on, the flower opens. And the opening of the flower, as you can see out here with the effectors, we have some effectors that I'll just turn on. We have some different effectors. A plane effector here that controls the rotation of the petals, and a randomness that adds a little bit of variation to the animation, and then a delay effector. And the delay effector really helps smooth things out, because when you're using a MoGraph to animate, you miss a bit of that easing in and out and wobbly motion, and the delay effector does that in a very easy way. Okay, so that's it for the flower, which opens up, and I have the perfume here, just a model with a couple of materials. No big deal here. The funnel object here is something we'll save for later. That's a later part of the process. And then there's the camera animation. Which I often do when I animate with cameras. If I can, I'm using this, creating 3 different still images for the first sequence here. 1, 2, 3, and then creating another camera with a camera morph tag, which has these cameras 1, 2, 3 in line here, and then I animate the blending between these cameras. That's a really, I think, it's a really elegant solution, because if I need to have something, let's say here, I might need to change this to another angle. I just change my still camera, and then I can. No, it's not looking good, but hopefully you get the idea. I think it's a really elegant solution to camera animation. It has its drawbacks because you can't control it as good as with regular animation, but it's very fast. Okay, so that's it, and then I've used the stage object to make cuts between the different cameras. This is cutting from one morph camera to the O2 camera, and to the next cameras. Okay, so this is it for the animation part of it, for the moment anyway. So now we need to get this into RealFlow, and there's, at least when we are dealing with MoGraph or particles or simulated animation, it's really important that we bake the animation. So I've added a MoGraph cache, and if we're using this, we'll have the animation. So what it does is it's recording every frame of the animation from all of these MoGraph objects, which is the pedals here. And that's really important because then we get some fixed animations, and RealFlow needs some fixed animation data because it doesn't have MoGraph, obviously. So we have some fixed animation data that we can count on. So that's really important. It's also important if you send things to Team Render, for instance, then by all means cache the MoGraph and the particles and stuff. Okay, so now we're just about ready for RealFlow work here. In the plugins folder here, we have the RealFlow tab here with different objects here, and we have the render kit. We're going to be using the render kit in the end of the project here. So, but at first here, we're going to be using the RealFlow SD exporter. The SD files are geometry files that is sent from back and forth between Cinema and RealFlow. So what I'm going to be using here is the exporter here. One thing I forgot to mention, I'll just cancel this. I forgot to mention we have the scene set up here. And let's activate the background. So as you can see here, I have a background. Let's turn this one off so we can see a bit better. I have a background here, and if I uncheck my stage object so I can decide my own camera here, as you can see, the backdrop has indentations here that kind of mimics the pedal shape of the animated object, and it's also, if I just turn off the subdivision surface, this is quite important as well for making things easier for RealFlow to handle. This is an enclosed volume. It's a solid object with a volume. Yeah, it's a solid object. So it's not just a single plane or polygon. Polygon planes. It's a plane with a volume, and that's really important because this makes things easier for RealFlow to handle in regards to simulation time and several other things. So once this is set up, we'll go to plugins, RealFlow SD exporter, and now we have this. Let's just remove all. In the beginning of when you first initiate this plugin, you have all your objects out here in the left window here. In this case, I want to add all of the objects and export them, and I want to save it up here. I'm saving it. This takes a little while today. To wherever I want it to. I'd like to keep everything organized within the same folder, including the RealFlow objects here. So I have this folder here. I'm saving it here, webinar01.sd. I'm clicking cancel. So, but when I click export, Cinema 4D goes through all of the frames in the animation and saves them out in this SD file. There's one thing before we get into RealFlow, one thing that's really important to mention. As you can see here, we have plane 1, 2, 3, 4, 5, 6. in this project, I haven't been that good at naming things. And it's kind of important to name things properly, so we have unique names for every object. In this case, it's not a problem because we can get it into RealFlow without any problems, but getting it from RealFlow to Cinema with all these objects, if we need the geometry back in Cinema, then we need to have unique names for everything. In this case, it's not a problem, because we're only moving the geometry objects from Cinema to RealFlow, and then we're only using the particles from RealFlow inside of Cinema. Hopefully this all makes sense when we get to it. So I'll click cancel to not make anything, to keep everything as I've prepared them. So inside RealFlow here, what we need to do, we have an empty scene here. We need to import, go up here in the import tab, import object. And then we just navigate to the SD file. This is this one, webinar01.sd, and hit OK or open. Sorry. So now we get this into here. I'll just turn off the funnel shape that we don't need. So it's a bit difficult to see probably, but let's get, okay. So now it's a bit easier to see what we're dealing with here. So this is the object in here, and if we scrub through the timeline, we should get some animation here. Yeah. So RealFlow has now imported all the objects, and it's including all the animation. So now we can start to create the simulations or the particles here in RealFlow. I have prepared this in another scene, so let's go into 01. Yes, we'll delete all data. Okay. And we'll have to wait for the SD file to load. This is it. Okay, so now we have the pedal inside here, and we can start to create our particles. And the idea with the particles was that I want 3 streams of particles moving up along the shape here and hovering above the flower up here. So we'll have to create an emitter up here in the tabs up here in the upper left. We have some different particle tabs, or a lot of different tabs. The first 3 here are particle tabs. Standard particles, that's the old particles. We have Hybrido, which we're not going to be using, but we'll use the Diverso particles. And I'm going to be adding a circle emitter. So this is it. I've added a circle emitter. It's difficult to see right now. I'm pressing 1 on my keyboard to see everything from the top, and then I'm going to be moving it outwards. There it is. I'm pressing 4 to get back. I'm zooming a bit out. Okay, so now we have the first particle emitter. It's a bit too big, so I'm going up here to the upper left here, to the scale tool. I forget this. I have to scale it down here. Okay, so now we're scaling it a bit smaller, and as you can see, there's an arrow here. This is indicating the area or the direction of the flow. So I can go up to my rotate tool, rotate it around, and as in Cinema, there are keyboard shortcuts to almost anything. So with these tools that you'll probably be using often, move, scale, and rotate, you can use ERT, and that, or no, sorry, W, E, and R. This changes between these very often used tools. So now we have this particle emitter, and let's just start a simulation. It's initiating, and then a short while it will start to put out a few particles. Not nearly enough, but this is indicating the direction of the flow. So okay, let's stop the simulation and hit reset. Yes. One thing we need to do is increase the resolution. We want more particles to come out from this emitter. So, and the way to do that is up here in the nodes panel. We have the emitter that we created, and RealFlow automatically creates this domain object here. And this domain controls several things with the particle stream here. So in here, as you can see, we have the resolution, which is set to 1. I'll just set it to 10 for now, and let's see if this doesn't increase the number of particles. Once we've done that, we need to add a daemon. And let's just stop this. Let's go up here to the tab with daemons. So, and the daemons are different kinds of forces that controls how the particles behave. It's you know, if you're used to cinema, it's very much like the some of the effectors and particle forces in cinema. So this is very much in the same way of working. Right now, let's create a D-spline. Okay, so now we've created this D-spline, and I'll just move it out to the side so it's a bit easier to see what we're working with here. Okay, one thing to notice here, I haven't touched this window before. As you can see, let's just get these things moved over here. Okay, as you can see, we have a hub here, and we have the emitter, the domain, the D-spline that we just added, and then we have a disk, which is not important right now. Let's just delete the connection here. So what this does is the hub is a hub for all of these different forces and objects that has to interact with each other. So now the D-spline is connected to the hub here. Then all the particles from the emitter, and therefore for the domain here, is affected by the D-spline here. So, and that's quite important. It may look a bit daunting at first if you're only used to cinema, because that doesn't really use this kind of a node structure that much apart from Espresso. But it's simple to use, and it's really a great way of organizing or you know, quickly keeping track of your connections. So what I want to do now is I want to adjust this particle, or sorry, adjust this spline daemon. So I'm hitting the edit button over here, dragging the cursor over here. Let's see, let's move that over here. I'm just going to be doing this very crudely, very simply for now, because it's just for showing the principles behind this. And let's look at it from above. I hit 1. Okay, that's pretty okay. I want to start at the center of the particle here, and I'd like this one to move over as well. Okay, so let's hit reset down here. Yes, and simulate. And what happens now is the particles are being born, and they should follow the spline up here. Probably not as much as we'd like it to, but we'll get to that. So now the particles are starting, and it's not really being affected. You see, it is turning a bit towards the spline, but not nearly as close as we wanted to. So let's stop the simulation, hit reset, okay, and then go into the spline daemons settings here. So I activate the spline daemon, go into the daemon here, and the parameter that's really important here is the radial strength. So if I crank that really high, let's hit the simulation again. You know, with RealFlow or any kind of simulation, really, it's very much a question of adjusting and resimulating, adjusting again, resimulating. So it's an iterative process. But I find that with as I put up here the the resolution here, it does have quite a bit of influence on simulation time. So I'm trying to keep it fairly low as long as I'm doing the initial simulations, and then cranking it up as I'm getting closer to the final product. It's when we crank it up, it will alter the liquid flow and it will alter the behavior somewhat, but this is a very good. No, it's really okay to use lower numbers and then just starting the more heavy simulations at a stage where we are closer to the right results. Okay, so this is one part of it. There's one thing that's important here as well, because I want to start this simulation and then I want it to stop emitting particles. That's an important thing to take with us right here. And let's see, that is in the. I have to do it in the emitter here. In the emitter, we have a speed setting here. And the way of animating that is just by command or control clicking here. We're at frame 9. I can tell by the lower left corner. So I command click speed here, move forward a few frames, dial in 7 or 0, and command click once more. So, and then when we reset, yes, resimulate, we should see when we hit frame 9, we should see a decrease in the particle number of particles. So, okay, so this is it for the first of the particle streams. To create the second and third particle stream, I'll go in and duplicate the. See, as you see, this should turn down. Yeah, you see there are fewer particles coming out right now, so it is working. Okay, the way I'm creating the next streams of water is by just selecting these two, Command D, Command D. So now we have 3 more emitters, and they're still. I don't know why they should be connected to this domain. So, and we have the splines here that is automatically connected to this hub. So, and now it's just a question of moving all these emitters. Let's go up here, move the emitter over here, and then, you know, fine-tuning the placement, which you know, that's a bit of a tedious job. So let's skip that. Okay, so let's get on to the next part of it. And let's go into O2. Yes. And we have a few more things set up here. Let's see here. Okay, so here we have the 3 emitters set up here, and we have the spline daemons going upwards here. I'm just going to go through this pretty fast because, you know, it's not that difficult. I've added a noise field here. I'll just take the move tool so you can see it. It's the yellow box here. What this does is it's creating a bit more interesting flow to the particles. It's breaking them up and making them a bit more interesting to look at. I didn't want that noise to affect all the way up. So inside of here in the noise daemon here, we have a fall off. You see we have fall off enabled. If this is disabled, then it works in the entire world scene here, or the entire scene. If it's enabled, we have the option to turn off the effects. Fall off of the effects. Okay, so this is one thing I've added, and apart from that, we have, as you can see here, a drag force, kill isolated, and a sheeter. And these daemons pretty much just fine-tune the look of the liquid. The drag force creates the noise creates erratic movement, so particles are moving a bit over the place, all over the place, and the drag force drags this movement a bit, so it creates a more pleasant movement, a more realistic movement as well. The K isolated is a daemon that kills the stray particles. If we have a particle that is moving outside of the spline daemon and moving outwards here, we don't want to we want to kill it so it doesn't fly away. And one thing more is the sheeter. When I did these simulations, the liquid looked kind of open and with too many holes, and it looked like blobs, different blobs, not really connected. So the sheeter daemon here creates more particles between gaps in the particle flow or particle cloud here. So that's also just to create a more pleasant particle look. Then we have the uplift gravity. That's just also a fine-tuning to move the particles upwards in a bit faster than the first test I did. One thing we have also, as you can see up here, we have the particles are stopping up here. I can, if I just scrub through this part which has been simulated, I've added a hemisphere from the geometry tab here. I've added a hemisphere, and that is also connected here to the hub, so everything is so the particles are colliding with this. Okay, so this is kind of it for the first part of the particle simulation I wanted to make. So what we need next is once these particles are lifted or hovering above this object, we needed to switch over to another domain and fall downwards. Basically, we need to switch it to another particle emitter and then let it fall down. And let's open. Let's open the next here. Yes, we want to. So this has been fine-tuned, and with all the hub here. Let's just turn this one off. We have the hemisphere here that we saw in the previous scene. Okay, so what we want to do now is I'll just make this a bit bigger. We have this. This is the same we saw in the earlier scene file. Now we want to move, when we get the particles up on top here, we want to move them over to another particle stream and let them fall down. The way we're doing that is by adding a filter daemon. We have it down here. Oh, sorry. There we have it. So a filter daemon that can filter the particles, and in this case we needed to filter over to the next domain, which I've said a couple of times. I'll get on it. Let's go up here and create a new domain. So this is demo domain 2. Yes, let's see what's happening down here. It's connected to the hub 1. We don't want that, so I'll delete the connection here, move it over here. And now we'll create a second hub. So I'll click the hub icon here, hub 2, and then we'll collect the domain here. So what we need now is we need to change the particles from domain 1 to domain 2. And we will do that by the filter daemon, which is here. I'll grab the filter here and go in and say target. Well, the target is domain 2. Okay. And the source, which has been set here, that's domain 1. Okay, so now the filter moves these particles from domain 1 over to domain 2 at a certain point in time or a certain condition. That could be with a collision or something, but in this case, I'll just want to use it as a switch. So I set the condition to age greater than 0. This is something that's true always. Once a particle gets born, it's always older than 0. And then I animate the activation here. So at first it's inactive, and then I think we have it here. At a certain point in time, I animate it on, so it is active. The this is just a lot of talk, and we can't really see much. So let's go into the final part of the RealFlow scenes here, where we have everything connected, and I'll explain what's going on here. And it just needs a few seconds to load here. Okay, and create these. So what we have here is we have the hub 2, we have the domain 02 with another name that's connected here. We have the filter, which is activating at frame. Can't remember around frame. Let's see here. You should be able to see it down here. I can't really see it. It's activating on at about this 180 or so. So now it's active. And sorry, because we have these two hubs, and over here we have all the noise fields, the uplift gravity, and all these things. We don't want that on the when we switch on the second domain. Then we want the particles to fall down, and we want it to collide with all the petals. We want it to collide with the where is that? I think that's the first plane, with the bait or the disk here, which is the surface down here, and we want it to collide with a funnel. And the funnel here is, if I'll just have to find it there. That's an object from Cinema. As I mentioned earlier, we would get to that later. I'll show it in Cinema in just a second. This is just a shape to help guide the particles into the center of this flower thing, and it's not, it's not visible or rendered out. But it's just guiding the particles. So I'm turning that one off, and I'm turning the disk and the funnel. Okay. And then I add a normal gravity here. So as you can see, I'll activate the gravity here, go up to daemon, and it's a standard physically correct gravity here. So once the particles gets moved over to the domain 02, it is affected by all of these forces and collisions that we have here. So, and that's really what's happening here. If I'll just go a bit back and show one thing more, because this is important as well. As I mentioned, with the resolution, I've bumped it up to 100 here, and it's very important that domain 1 and 2 are identical in this parameter. And as you can see up here in the upper left corner, we have 790,000 particles. So we have quite a lot of particles. And I'll just hit play. It's not going to be playing back that fast, but it should be going once. So now all the particles that has been simulated and has been cached and saved to disk, they're being read and shown here in the viewport. And it's quite a lot of data, and I don't have the fastest disk, so this could be faster on a faster machine. Let's skip here. Okay, so this is pretty much it for the RealFlow part of the project. I'll just hit stop here and scrub here. As you can see, this is falling down and spewing out all over the place. So once we've simulated this, we're pretty much done with the RealFlow stuff here. So let's get back into Cinema, and I'll just revert to save. So yes, I do. Okay, so now we're here. We're here where we started. The funnel, as you can see here, that's just a shape here I've exported with. We don't need it right now. Okay, so to get the particles into Cinema again, we have a couple of options. We could have used the RealFlow standard RealFlow plugins here. We could import particles and we could import mesh if we generate the mesh from RealFlow. But I'm really fond of the RealFlow render kit because it keeps much of the work in Cinema, and I'm most confident with Cinema. So I really like that. And I'll create a RealFlow render kit mesh. As you can see, I have one up here that's prepared. And in the this object, I go to Particle Files, hit the Browse button, find my particles, which are here inside of the particles, RPC, and then I'm going to find these are the particles, flower domain 01. I don't need to pick the first one. I just pick one in the flow here, and I have another particle sequence here. That's the domain 02. So now this object reads all my particle files, and we have a pretty nice playback inside of Cinema. It does, start to slow down when we have this many particles. But this is I think it's really a great way of working. And then we have to go back and forth between RealFlow and Cinema a bit if we want to fine-tune some of the Cinema animation here. If the pedals are moving another way, then we go up here and export again, overwrite the SD file that we created earlier, and then inside RealFlow we can update that. So we can work back and forth all the time, and that's and you can have several people working at the same time. So, but we need to get this thing done. So I'll just create this one that has been prepared. Again, here it's a question of finding the right settings. In this instance, I ended up with 0.018 for the radius of the particles. In here I can create the mesh, and that was the polygon size of 0.02. RealFlow works in meters, so a value of 1 in RealFlow equals 1 meter, which is kind of important to at least to know in regards to these the figures you're having here, which might be if you're working in centimeter in Cinema, then you shouldn't expect the same in this RealFlow thing. RealFlow object here. So this is it, and then I added a bit of filtering. The filtering adjusts the mesh a bit, and it's a question of seeing how it looks. It's just for fine-tuning the look of the mesh. And then in this case here, the last important thing to notice here or to go through is the display. Right now I'm showing the particle cloud and I'm showing it as circles. I could use it just as particles as you saw before, or as boxes, or one box. I'm showing it as circles with a radius of 1. I just kind of like that. If I'll turn this one off, I also have the option to show the actual mesh. And as you can see, this doesn't look at all like my particle cloud, but that's because I've set the level of detail to 20. So if I'm bumping that up to 100 and updating, it takes a little while, but then it shows in the viewport the exact mesh that it renders out. So for seeing if things are correct and looking the right way, this is a pretty fast way to work instead of having to re-render or having to render the frame all the time. So, but let's not show mesh and go in here. Yes, well, this is basically the things I want to be showing you with the in regards to the RealFlow and Cinema interaction. Now we have to render this and get it into After Effects. So I'm opening my render settings here. I'm saving out the sequence of the regular image, and then I've added some multipasses, refraction, reflection, depth, and object buffer, and rendered an image sequence with these multipasses. I haven't really gone into the materials, but if you're used to Cinema, this is just standard materials in this golden color that I have on the pedal shape itself. I've used the kind of new reflectance shader, which is really really awesome, I think. So I've used that, adding some diffused reflection and a sharp glossy reflection on top here. So then I just hit render and go into After Effects. And this is the rendered results right here. We have the liquid moving upwards over the object here, but this is kind of okay looking, but we can increase or enhance the look of this with just a few steps here in After Effects. So first of all, I've added the refraction pass here, which is just everything that's seen through the liquid. I've added that on top of the straight render here with an add blending mode, and then I've turned down the opacity. So what this does, let's see here, it just gives a little bit more power to the look of the liquid. And I've also done just about the same with the reflection pass. As you can see, it creates a bit stronger reflections especially on the flower here, and it should do something extra here to the reflections on the glass or the liquid surface. And then I've added some contrast. If I'll just turn everything off, I've added curve adjustment, another curve adjustment, and depth of field. There are different solutions on the market. I like Frischluft depth of field. I've added that, and then I have, if you look down here at my depth pass here, this is the depth pass, and inside of my Frischluft here, let's turn this one off. I'm using the perfume depth map as a depth layer, and then I can go in and click and tell Frischluft where I want my my sharp area to be, or focus point. So as you can see now, this is sharp, and the rest is blurry. And if I click one of the pedals in the back, so I can adjust it in After Effects as opposed to rendering it out straight from Cinema, where I'm locked to the settings I've created in Cinema. So here I can do it in post. And then I've added just a little bit of an extra effect. I've added some, let's go over here to another. I've added a bit of motion blur. I've added slight vignette, and then I've added the text in the end here. And it just has to open up here. So, and if you look at this, you know, it's quite a big improvement with just a few steps. Or at least I think it is. I hope you do so too. Yeah, well, I think this was all I wanted to tell you. Let's just look at it once more. This is the final ad, liquid hovering and floating down. You know, I wouldn't exactly say this is an easy project, but then it's not that difficult, at least not if you know Cinema, and if you've spent a bit of time with RealFlow, then it's definitely something that's pretty straightforward to attack this kind of project. Then there's the fine tuning, but you know, that's always a big part of it. Yeah, so I think this is what I had to show you. I hope you enjoyed it, and I believe there's a bit of time for questions afterwards. Now, if you have any, please keep questions related to the project here. It's as Andrea said, it's not a support session. So if you have anything regarding this, please feel free to ask, and I'll let Andres and possibly Thomas Schlick as well take over. But if you have any, please shoot them.
Well, first of all, thanks, Thomas, for that fantastic explanation. Even the marketing guys know more about RealFlow and Cinema 4D now. Well, waiting for questions. Feel free to ask.
Yeah. Yeah. I could, you know, if we're waiting, we have a few minutes. I could go in just something I haven't shown. Not really that much RealFlow related, but I didn't show the scene setup. If any of you are interested in that, I'll just turn off my stage and go outside of the camera.
Well, we have.
And let's look.
It seems like we have at least a couple of people who want to ask questions. I just go through them.
I can just, while we're, I'll stop the minute we get something. I'll just show my my scene setup if any of you are interested. I have a top light and a left and right fill light. Then I have a rim light to you know, get some nice rim lighting here. Let's go into the one of the cameras here.
So we have another attendant, Dieter Krause. Dieter, can you hear us?
Hello.
Hi.
Can you hear me?
Yes, we do.
All right, cool. I would just like to know how you have added the motion blur in After Effects, since I didn't see any paths in Cinema for it.
Repeating the question. The question was how do I edit the motion blur in After Effects because there's no motion pass from Cinema. Well, this is just the pixel motion blur effect from After Effects. It's a built-in effect in After Effects, and it works kind of the same way as Real Smart Motion Blur, if you know that, where it calculates from the previous frame and the following frame to see which direction the motion is headed.
All right,
so
cool.
that's it. I didn't really. Oh, okay, fine, thanks.
All right, so we have Horst Dubel who had a question.
Can you hear me?
Yes, we do.
Good. First of all, thank you for a very nice presentation. And my question is simply, can the particle effect which has been created in RealFlow be achieved in cinema only, like using thinking particles, for example?
I would say the simple answer would be no. And the more complex answer or longer answer would be yes, it could. It could to a high degree, I would say, but you know, this is what RealFlow has been built for, so it is better at these kinds of things. But yes, it would be possible to create thinking particles, adding collisions, and I'm not sure about this, Andres, Maxon, if thinking particles can handle these number of particles as efficiently as RealFlow does.
Well, we always have to keep in mind that RealFlow is a software that is created exactly for that purpose, and I'm pretty sure that it would be a bit easier for people to use RealFlow instead of thinking particles. But as I'm just a marketing guy and not a Cinema 4D expert, that is something you might want to ask in one of our possibilities to ask questions to Maxon on our website, for example. Or if you ever come to one of our events, probably our specialists will be able to answer that question in depth.
And there's one thing I think that's important to mention with this question. Some time ago, there was an announcement about RealFlow Core, which is not ready yet, but it's being worked on, which is a plugin plugging directly into Cinema. So you can use the RealFlow tools, not the full RealFlow tool set, but you know, many of the tools directly in Cinema. So it's a plugin that's integrated directly into Cinema, so you don't need to leave Cinema to work with RealFlow.
All right, whom else do we have? Enrique, what's your question, Enrique?
So I sent the question in the chat, but I will do here too. When he exported this shape from C4D to RealFlow, he said he can rename the object if need to import the object from C4D directly from RealFlow to C4D. So how he can do that? Rename the name of the object to export from RealFlow inside Cinema 4D.
Yeah, it was a bit of a shaky connection, but I think I got the question. It was regarding renaming the objects, so I can, yes, import from RealFlow to Cinema. The challenge with the exporting is that RealFlow needs, you know, if we do some kind of dynamic simulations or do something to the geometry here, and we need to export that geometry to Cinema 4D. We need to have see, I'm not allowed here to rename it. And Thomas Flick, you may correct me if I'm wrong, but I'm not sure it's possible to rename it inside of RealFlow.
It is actually possible, but once you have imported objects from another application, then the name is fixed and cannot be changed anymore. And this is just for interchangeability. If you change the names in RealFlow, you might get a completely different output inside your 3D application, and then the names don't match anymore, and any motion you record for body dynamics, for example, would be lost. So this is why we maintain the names inside RealFlow from imported objects. If you create objects inside RealFlow directly under the geometry tab, there you have a few basic objects, then you can rename them freely to your needs and export them. But imported objects from different applications cannot be renamed.
Okay, understand. Thank you very much, and thank you for this presentation. I love that.
Oh, thank you, thank you. One challenge with in regarding cinema in this project was that I was using the a MoGraph object, so I'm not allowed to rename the individual MoGraph objects. So I don't have complete control of the naming when I'm using this when I'm using MoGraph. So that's why it came into RealFlow with plane 1, 2, 3. That's how the exporter. Let's see here. Plugins, RealFlow export. That's how the exporter understands these objects from the MoGraph cloner here. So I don't have complete control over that. But you know, if you didn't use MoGraph and you've animated the regular way, then you can name every single object with a good name or a unique name.
Yes, now I understand. Thank you very much.
Okay, thank you.
So let's see if we can get someone else. Joel Harris. Joel, can you hear us?
Yes, I can.
Ah, perfect.
Hi.
Good. First of all, thanks very much for the presentation. It was very well organized and planned and everything. My only question was how much tweaking within RealFlow was necessary to get the little kind of liquid tendril shapes and all that kind of pretty splashy effect? Was there a need to tweak settings as far as, I don't know, surface tension and that sort of thing in order to get that, or did you pretty much just use the default settings for the nodes within RealFlow?
There was some tweaking, but the basic tweaking is pretty fast, because once you start to dial up and down in the parameters, you get quite a big impact in the look. So, but it was, I didn't tweak many of the parameters. Also as mentioned, I'm pretty new to RealFlow, so I don't know every little parameter. But and by the way, right-clicking and go to Help here is a godsend for stupid new users like me, because you get an explanation of the parameter. So, but basically it was getting most of the time was spent getting the right speed and size of the particle flow, with the size of the emitter, and with the let's see, the splines here, with the radial strength. I tried a bit of the axial and vortex strength, so I got a pleasing motion upwards. And then the noise field, that was also a very important, the noise field here. And I tried a bit, with the strength, and ended up having to animate the strength to get the look I wanted. So if I dial down to, let's say, frame 69, the strength, as you can see here, is 8, and at a later point in time, it's down to 6. So, so I did some tweaking, not with many parameters, but with a few of them. And I think the thing that improved the most was the, where is it? The drag force. It's it's really a low force, but that helped slow down the liquid a bit, because it was a bit fast moving, or the noise was a bit violent, but the drag force toned that down a bit. And then the let's see, where is it, the sheeter, and that's really a good thing, because when you have holes in the mesh, and when you have some particle groups that gets torn away from the blob of the mesh, so to speak, then it helps create bridges between these meshes, and that really improved the look quite a bit. So that's an important one.
Okay, thank you very much. That's good to know. I don't have any experience with RealFlow. I've just been using Xparticles with Cinema 4D, which does a fair job with fluid, but nowhere near the realism of simulation that RealFlow is able to achieve. So this has been
That's good to hear. Thanks.
It's been very informative. So
Great.
Thank you.
Yeah, you're welcome. Thank you.
All right, so maybe we take another question from the chat. The question is from Charles. Why hasn't Thomas shown us the meshing parameter before exporting to Cinema 4D? Thomas, could you answer that?
Yes, that is because I'm not meshing in RealFlow.
I hope this answers Charles's questions. Oh,
yeah,
here we have.
I can go into the RK mesh. I'm doing all of the meshing inside of Cinema here, where I'm using the meshing tools here. I believe, and please correct me if I'm wrong, Thomas, I believe there are more advanced options inside of RealFlow itself.
Yeah, mainly for making channels visible, like velocity, vorticity, pressure, and so on. But the basic parameters to control the geometry are exactly the same as in RealFlow. So on the particle files, you have some of the parameters, mainly for adjusting the particle's radius and how they will be blended together. And then the mesh, you can control the geometry. And display gives you the possibility of showing everything in the viewport. So
one thing I think that's also important to mention, that we can hear directly inside of Cinema 4D with the plugin here. We also have all of these channels that can.
Yeah. You can take them into vertex maps to control how the fluid will be rendered. You can make attributes visible, like velocity, for example, force, or the number of neighbors. And that's what they're good for, these channels.
Yeah, and for my case, it's really, really great that it can be done directly inside of Cinema, because that's where I spend most of the time. So, yeah. I hope this answers the question.
Well, hopefully, as it was in the chat, we can't say for now. There's another interesting question coming from Tel Aviv, from Jambo. Well, familiar face from the Cinema 4D community as well. He asks about the integration with third-party render engines. Thomas, do you have any experience with things like Arnold or something?
I don't have with Arnold and Octane, for instance, but I'm using. This has been rendered with Cinema's own advanced render, but I'm using much of my time. I'm using V-Ray, and I've rendered some RealFlow stuff with V-Ray, and it worked out really well, because once things get into Cinema 4D, it's just basic geometry. Once the render kit mesh object here has done its thing with the meshing, then it's just considered a regular polygon object.
Well, but I just found someone who can certainly answer these questions. I saw that Daniel Hanius from Ugly Kid is waving. I'm enable his voice. Daniel, can you hear us?
Yes, hey there. I just wanted to chime in quickly on the regards of the compatibility to third-party renderers with the render kit meshing. Indeed, as you can see, there's a Arnold tab in the render kit attributes window. So that means that if you are using the Arnold renderer, it directly generates the mesh at render time, so there's no need to export them to geometry or whatever. And the other feature that is exclusive so far as I know is that there's a real motion blur capability working with Arnold. As to my knowledge, it's not working with Octane or V-Ray up to today.
Not with Octane, you're absolutely right, Daniel. With V-Ray, it sometimes works. We don't know why, and the guys from V-Ray don't know it as well. We're not clear on which side the problem actually lies. Sometimes it works, sometimes not. I don't know why really. It's a mystery right now.
Okay, well, for my part, I never used V-Ray, so I can't really comment on that. But the thing is that it would also generate some motion blur effect with the physical render, but the thing is that the effect is wrong. So working and working can be two different things. But so far as I know, that from within Arnold, it works as it's expected to be. So that much I can tell.
Okay, thanks.
So it was great having Daniel, who is a very experienced RealFlow user and also Arnold specialist here to answer that question. And thanks also to Thomas. There's another question from Eduardo Lopez, who asks why you did use 2 domains instead of 1.
Yes, that was because I wanted. Let's go back to the QuickTime here. I'll just go in here. I wanted the to hover above the shape here, and then switch to a falling motion. So I figured the easiest way to achieve that would be to take the particles from one domain to the next, because in this part of the simulation, the particles are following all of the spline demons. It's colliding with the hemisphere we have up here. It's being affected by the uplift gravity and the sheeter and the other domains. And then I want to switch it to this point where it starts to see the funnel shape, so it collides with that. Sorry. It collides with the funnel shape, and it falls downwards and being affected by gravity. So if I wanted to do that with one domain, as far as my knowledge goes anyway, I would have to, at some point in time, animate a lot of parameters. The parameter for the funnel, for instance, I would have to have that turned off until I want to make the particles fall down. So I have to turn that off at first and then turn it on, and turn the gravity on at a certain point in time, and turn the spline demons off at that point in time. So so it could be done by just keyframing all these elements, but moving them over to another domain seemed a lot easier, because if I want to adjust afterwards and say, well, I wanted to shift it at frame 150, for instance, I want to turn on the switch at that point in time, then it's just one single parameter I had to animate, which is the active or inactive. So that's why I use that.
All right, there have been a couple of questions regarding the system you use to process the whole thing. Maybe we should take this as a last questions because we are already a half an hour over time.
Yeah, this is my current system, and for rendering and for simulation, it's quite a capable system. I'm lagging a bit on graphics power, but yeah, you can't have everything.
All right, so thanks to everyone for watching the webinar. If you haven't seen that in my chat message, you will establish an email address, which is will be called webinar@maxon.net. So if you have any questions after the webinar that are connected to this webinar, just drop us an email. Please allow me some time to install that email address. It will probably be tomorrow morning. And hopefully we can answer most of the questions. We'll also cluster the most asked questions and do a little leaflet that you can have after the webinar. Well, thanks for watching. Thanks to the Thomases for sharing their knowledge, and I'm pretty sure we will see you in another webinar on Cinema 4D related stuff soon. Have a great day, evening, whatever time zone you are in. Bye-bye.
Bye.